So hello friends, in this video we will talk about the TensorFlow, which is having multiple dimensional inside the deep learning. So first we will consider it all starts with a tensor. So a task in a deep learning would revolve around processing an image, text and tabular data. So after discussion with the TensorFlow, we will talk about the coding part, which is having the how tensor is going to be created, how it is having two-dimensional, how multiple operations are being performed upon the tensor, and so on. So first, we must understand that what's the scalar tensor. So first it is a zero dimensional tensor and which is having only six element. Then we are having one dimensional tensor which is actually a vector. So we can say a vector is a synonym of a tensor. Then we are having two-dimensional tensor in this matrix 1, 2, 3, 4, 5. 5 columns are there, 1, 2, 3, 4, and 4 rows are there. So 4 into cross dimension of this tensor. So but we will call it two-dimensional tensor. Similarly, we are having three-dimensional tensor and the vector format of the different. So PyChart is very rich library that provides numerous functions that enable building blocks for deep learning. So coming towards the creating tensor, how to create tensor. So before creating the tensor, we must have that import torch. So we prerequisite library is import torch only, not the rest of the elements. I'm going to remove all these elements and then going to import only one library, that is torch. Then I have created two elements, zero point 0.1 and zero point 0.2, zero point 0.3 and zero point 0.4. I'm going to run this command which is saying that you have created, once I have created the library which is called torch, and then I have created a torch and tensor of two-dimensional. Then I am having the second tensor, that is zero point 0.1 and 3. What is the size of this tensor? That is 2 cross 2. Suppose I want to print this tensor, I will write just A and it will print it out on the screen. Then I will create the second tensor, that is B is equal to torch dot tensor with the second dimension. So this time this is again two-dimension tensor but having different columns over there. Second, I'm going to create one more tensor, point 0.1, point 0.2, point 0.3 and point 0.4. So I'm going to print on the screen these four values. Then I will print again this tensor. Why I'm showing this error? Because I have not import the respective library. So import numpy as np. So this will import all these module respective module to have that array function. So I'm having that numpy array, and this numpy array will convert torch from numpy array. So I'm going to create that numpy array and going to convert from numpy array to tensor. So this tensor will have parenthesis and then a square bracket inside. Again, I can create random values for tensor, that is the random function. You can see I have created 2 cross 2 cross 2, means 2 cross 2 is one dimension, and it is having index number 0 and the second is having index number 1 respectively. So I have created two tensors over here that is going to have the different values. So if I would run again this command, so it will have different values. So right now it's first value is 5398 after the decimal value. Now second runtime it is showing 9229. Okay, so in the same way I can have the zeros inside that run inside that tensor. So this is all zeros. This is how you can create all zeros. So I'm going to print all zeros over there on the screen. Then it will have 2 cross 2 cross 3. Similarly, I can create ones torch 1 comma 3, and then ones which consist all these values as one only. Similarly, I can have eigenvalue or the diagonal which is having only diagonal values on the matrix on the tensor value. So it will have the diagonal value as a 1 only. That is the I vector. So similarly, I can have the full value as 42.42. So I'm going to print this 42. So this will have 4242 everywhere with 3 cross 3 size. So this tensor is having 3 cross 3. It is again two-dimensional tensor, but right now it is having all these value 42. Similarly, we can have the line space, which is the undefined function in the Python or the NumPy or Pandas, you can say. So I can have the len function also. I can once I will print this len function, it will have that value in between 0 to 20. I am going to divide this 0 to 20 into 5 parts, 5 equal parts. Suppose I am going to divide this, not this type 5. This time I'm going to replace with 10. So it will give I divide 0 to 20 with 10 partition. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 equal values on the x-axis, you can say. Again, I'm going to create one more tensor, and it will have tensor 1. So this time I'm going to tensor 0, so it will print all the zeros on the screen. Similarly, I can have the float tensor. So it is the parsing, it is the data type which is having random. So I'm going, again I'm having tensor which is having random value. So this time I'm going to use that any function which is having a is greater than 0. If any value is having greater than 0, it will print it will print true. Similarly, I can have one more value here. Suppose I will have less sign over here. So I will have that it is false. Similarly, I can add one more things here. B is equal to a plus asterisk. So I'm going to perform e raised to power, that is 10 raised to power minus 3 value with the same function. This is the multiplication sign and as well as the addition sign. So I'm going to print this function. So this is the arithmetic operator on the tensor values. So arithmetic operator on tensor. This is how we create arithmetic operator on tensor. Then I'm going to create this b value over here on the screen. So a is equal to a torch tensor, and it is having the three dimension also. Then I'm going to have b torch dot abs a, and I'm having this b again. So it will have the absolute value of these 1. So few numbers are having with negative sign minus 1, and few one are 1. So this function abs is going to convert into the absolute value. So I'm going to convert the, suppose I will give the random value to the 100. So it will give the, this time it will give the higher integer value with 100. So this time I can have more values over there. Suppose you want to random numbers in the near about triple nine. So this time you can have multiplication with 1000. So right now I am having this much of number. So I can give the floor value also. So floor of a, so I'm going to have that floor, and removing all these decimal value, all these float value, uh, will convert it into the integer value itself. So it is going to convert into the floor values. Similarly, I can have that floor tensor, floor tensor, I can convert into the floor tensor, then multiplication of C. So I'm going to convert into C. I'm going to multiply this A and B and using this multiple function. So this is the I may print this a value also. What is the a value right now? It is just 0.883 and 3. So I'm going to dot wise matrix multiplication, this O and then 0.53 and this O, then this one. So this is the multiplication of the values. So I'm going to again print this. So this is having multiplication part. So this time having this value 0, this value 0. You can see this value 0, 0, 0, 0. 4 times it is 0. So here I'm also having 0, 0, 0 and 0. So rest are as it is because I'm going to multiply with 1 for rest of the values. So it is going to print all these must values with the zeros. So then I am going to float values of this one. This time I'm going to divide a and b two variables. So using the tensor flow, I can divide two variables also. Similarly, I can find out the sine function. So this is the trigonometric function over tensor flow. Similarly, I can have that sigmoid function also. Sorry. So this sigmoid function will print all these respective values of sigmoid. So this is having that sigmoid. So in the next chapter, we will learn about the neural network and this one.